Good morning, folks. Happy Friday. Uh, Mr. Lopez, your science teacher here, and we're going to be covering today, we're going to continue to learn about spiders, their different features, traits, and we're going to be looking at a modeling tool to look at our understanding of how protein molecules interact to determine traits. Uh, we have a silk flexibility model, which you see there. This was homework page 21 that we have been working on. Well, we actually haven't worked on this page, but excuse me, page 21. This is the page that we have not covered, and we will be doing that today. So make sure that you're on page 21 because that is what we will be covering. And we're going to be looking at two different spiders. As you see there on page 21, we have two different spiders, spider A and spider B. Or we can call them, Greg or Zora, and I'm going to explain why. So we're looking for a spider that has high silk flexibility. So if you look here, we have features of a spider, right? And the one that we're focusing on, if you look at the top of your page, it says there silk flexibility model. So we're looking at the silk flexibility feature, and we need to locate a high silk flexibility and a low silk flexibility. So low silk flexibility and a high silk flexibility trait. The traits are here, right? Here are the traits. They're located right under the names. Um, and we're looking for a high and a low. So Greg is a low silk flexibility, has a low silk flexibility trait. And Zora. Now I could have picked Anne, right? Anne has a low silk flexibility. Or I could have picked Otis. Otis has also a low silk flexibility, but let's go with these two, Greg and Zora. And what we're going to be doing is we're going to be looking at their protein molecules. So we're going to be clicking on their name, and we're going to be looking at their protein molecules. So we'll start with Greg. Or on our books, what we can do is we can write Greg and Zora. That would make a lot of sense for us to do that. So let me move this over here. So we have Greg here, right? And we have Zora. So we're zooming in, as you can see, we're zooming in on their cells. These here, these circles, these large circles are cells. These are Greg's cells, and these are Zora's cells. And inside their cells, they have these shapes. We have right here what we have what's called the nucleus, which is the brain of the cell. And we have also can't get a darker green. So, well, let's see. Orange. Can we get orange? Yeah, we can get orange. So these here are ribosomes that you see here in orange, kind of shaped like a diamond, a bit like a diamond. And they're ribosomes, and these are where the proteins are made. Ribosomes, and I'm probably going to have to type that in the chat so you can see it. So we have ribosomes, and what we want to do is we want to take a look at the protein molecule structure of the high and low silk flexibility spiders. And where is that located? Well, it's located right here. You will either see this protein molecule structure 1, 2, or 3. You're going to see one of these three floating around the cytoplasm of the cells. All right. So let's go back and let's click on Greg. If we click on Greg, we notice these pink-looking shapes floating around. And do you see how they're popping up? They pop up from the ribosome. That's because the ribosome is making. There's one that just popped out there. Another one. Another one. And so these the shapes are determined by the nucleus. The nucleus, which is the brain, sends a message to the ribosomes to build these types of protein molecules. So which ones do we see floating around? If you notice, we see they kind of look like a comb. For me, they look like a comb. Maybe they look like a certain shape to you, but looks to Mr. Lopez like they are protein molecule number 1. Do you see protein molecule number 2 floating around anywhere? No, I don't see it. How about protein molecule number 3? Do you see protein molecule number 3 floating around the cell? No, I don't see them either. So this is what we will draw when we head back to our page. Here we are. So let's draw them in pink, right? And we'll just draw 2 of these. All right. Now, let's head over to Zora that has low silk flexibility. Zora has low silk flexibility. So let's take a look at, actually, you know what? I made a mistake. Mr. Lopez made a mistake. And he's reading it carefully now, and he's just noticing something. So what I noticed was Greg, right? High silk flexibility. Let's look at Greg. Greg is low. So Mr. Lopez made a mistake. And it's okay to make mistakes. It's awesome to make mistakes because that's how we learn. So what Mr. Lopez is going to do is, that's why we have erasers. So Greg has a low silk flexibility. So all we have to do is switch Greg and Zora's name. So Greg, again, has low silk flexibility, not high. And we're going to switch Greg and Zora's name. So Greg is here. And Zora is over here. Now let's look at Zora, and let's look at Zora's protein molecule structure before we erase this and find out if it in fact looks comb-shaped. Actually, it would not. So it's Greg. This is Greg's protein molecule structure. So we actually have to go back. We have to erase this. And we would want to put them on Greg's side. And that's what Greg's protein molecule structure looks like. Now we're going to look at Zora's side. Maybe we'll add one more here. We're going to look at Zora's side and look for Zora and look at her protein molecule structure. Select spiders. Let's click on Zora. She's a female. And these are the protein molecules that are floating around. Again, Zora has a high silk flexibility, right? She has high silk flexibility. And which protein molecules are floating around? The protein molecules that are in pink. Okay, so we have, is one floating around anywhere? These pink looking shapes, do we see one? No, we don't. Let's get our pen and let's just mark off one. There is no one. Do we see two floating around? Yes, we do. We see this one here, and we also see three floating around. Here's two of them. So we do have protein molecule 2, and we also have protein molecule 3 floating around. So let's go back and let's draw those two. So we have 2 and 3, which looks like that, and like that, like that, and like that. All right. So what do we notice? Well, what we notice with protein molecule number 2 is that it has fewer connections. So I think it will form silk with higher flexibility. So what we have here is we have fewer connections. And we have fewer connections here. With Zora, and with Greg, we have more connections. So for Zora, since we have fewer connections, it would form silk with higher flexibility. So with fewer connections, we have higher flexibility. With more connections, we have low silk flexibility. And that would be our response. Okay. So if we look at these three protein molecule options, 3, protein molecule number 3, which is located here, right, would produce high silk flexibility, as opposed to Greg's molecular structure, which produces low silk flexibility. Okay, more connections, fewer connections. And that's it, folks. All right, you guys did a great job today. And you should now be able to turn in page 21.